Thank you for watching my video once again. My name is Mr. Charles Weniken. In this video tutorial, we are still on fuse. Just as I said, I will not tell you that this fuse topic or video tutorial will be 7 or 8 or 9, all depending on the video. So in this case, this one is another tutorial on fuse. Now, in that case, remember we discussed on the other one-time only fuse, which I told you that these are types of fuse frequently used in electrical and electronics system in house, in our home or office, as well as industry and so on and so forth. Now, in this case, we are to discuss resettable fuses. Now, resettable fuses, on the other hand, will be automatically reset after the faulty has occurred by changing its resistance. I repeat, the resettable fuses, on the other hand, will be automatically reset after the faulty has occurred by changing its resistance. The other classification is based on current limiting resettable fuse and non-current limiting resettable fuse. Now let's move forward on that. Now what I'm trying to explain here in this resettable, I want you to understand that this one is and automatically reset by itself after when the current has changed its resistance. After the faulty has changed its resistance, this one is automatically reset himself after the faulty has changed its resistance. So in that case, it has been classified into current limiting and not current limiting. Now let's proceed forward. Now, in that case, current limiting fuse being under resettable, current limiting fuse introduce high resistance in the circuit for the short period of time. Remember that they have two types, current limiting and non-current limiting. So current limiting is telling you that introduce high resistance. In current limiting, it introduces high resistance in the circuit for the short period of time. While in non-current limiting fuse, as soon as the excess current flow, the gases in the fuse produce arc that interrupt the current, which means in that case, the simple differentiation between the current limiting and non-current limiting is this. Current limiting introduce high resistance in short period, simple, while in times of non-current limiting, what they do is what? If there is an excessive current flow in the circuit, the gases in the fuse produce arc that interrupt the current. So it means that both of them, they have different function, but they are under resettable fuse. Now let's go straight to types of fuse. Types of fuse. There are many types of fuse available for a variety of applications. There are different types of fuse for different application, different kind of application, all depending where you want to apply or you want to use the fuse. Now in that case, the main category of fuse are based on the type of circuit they are used in. For example, AC fuse and DC fuse. Now, do you understand what I am trying to explain here? The main category, as in the main different part of it is depending on the type of circuit you are using the fuse for, which I mentioned AC fuse and DC fuse. Again, AC fuses or fuse are divided into high voltage fuse and low voltage fuse. So in that case, we will as well discuss each and every one of them in details. Now, in this case, if you remember what I said about this AC fuse are divided into high voltage fuse and low voltage fuse. Now let's go straight now. Low voltage fuse under AC fuse. Low voltage fuse under in AC fuse are used for voltage less than 1000 volts. Low voltage fuse under AC fuse are used for voltage less than 1000 volts. Low voltage fuse are again classified into cartridge fuse, bracket and close, total enclosed type. Secondly, rewindable fuse, bracket and close, semi-enclosed type, switch fuse, drop out fuse, and strike fuse. I will discuss each and every one of them in this tutorial as time goes on. So in that case, what I'm trying to explain here, in the same low voltage fuse are again classified into cartridge fuse, which is total enclosed type. Another one is rewindable fuse, which bracket and close, semi-closed type. Another one is switch fuse. The next one is drop out fuse, and the last but not the least is strike fuse. We will discuss them each. Now in that case, high voltage fuse in the same AC, which I told you we have low and high. High voltage fuse in under AC are used for voltage above 1000 volts. Remember, in times of low voltage fuse is used below 1000, which means that from 0 volts to 1000 volts. Now in this high voltage fuse, it's used above 1000, which means from 1001 volts and above. High voltage fuse are further divided into cartridge types, which is HRC, which means high rupturing capacity fuse. Another one is liquid type fuse under the same high ROC, being HRC fuse, and explosion type fuse. I repeat, high voltage fuse under AC fuse are used for voltage above 1000 volts, which means it's from 1001 and above where we can use those fuse. Now, which involve high voltage fuse are further divide into cartridge fuse, which is high rupturing capacity fuse, liquid types under the same high rupturing capacity fuse, and explosion types fuse. Now in this case, the following image shows the charts of fuses divided based on the AC and DC current. Remember what I have just said before. In types of fuse, I told you that the main category of fuse are based on type of circuit that you are to use it for, which I say, for example, AC and DC. I now go forward again. I say AC fuse are divided into high voltage and low voltage, which I have explained before. I repeat, I told you that a low voltage fuse are used less than 1000 volts, which from 0 to 999 volts. Now, why the high voltage fuse, which I gave you an example of low voltage fuse, is a total enclosed type, rewindable fuse, semi bracket and close, semi-enclosed type, switch fuse, drop out fuse, and strike fuse. That is for low voltage fuse. Now, in that case, again, I also tell you about high voltage fuse, which is used above 1,000 volts from 1,001 and above, which is again further divided into cartridge, which we have high rupturing capacity fuse, liquid types, and explosion types. So in that case, let's go straight to see the chart of fuse, how it divided, how it is. Now these are the fuse, DC fuse and AC fuse. In the same area, we have AC fuse, which I have already discussed before, AC voltage fuse, and high voltage fuse, and low voltage fuse. High voltage fuse, which I said before, cartridge types HROC, being high rupturing capacity fuse. Which one is this one? The same thing as in liquid types, and this one is the same as explosion types. In terms of low voltage, is the same thing. Just I have already said before, we have renewable fuse types, cartridge types, add drop fuse types, strike, and switch fuse. In the standard cartridge types of fuse, we have D type cartridge fuse and link type cartridge fuse. The standard link type cartridge fuse, we also have both type and knife blade type. We will discuss each of them one by one. Remember what I said, low voltage fuse are used in times above less than from 0 volts to 999.9 volts, while high voltage fuse are used from 1001 volts and above. Now let's go straight to DC fuse. The main difference between DC fuse and AC fuse is the size of the fuse. In DC circuit, when the current exceeds the limit, the metallic wire in the fuse melts and disconnects the rest of the circuit from power supply. I have explained this over and over and over. What I mean is, when the current is above the fuse rating, definitely the wire inside of that fuse will cut off. It will cut off to prevent other circuit not to be damaged. That is just how it works in times of DC circuit. When the current exceeds the limit, the metallic wire in the fuse melts and disconnects the rest of the circuit from power supply. DC circuit is constant value and is always above 0 volts. DC circuit is constant and is always above 0 volts. There is a chance of electric arc between the met wires, which will be difficult to avoid and turn off. That is the simple truth. That is in terms of the fuse. You know, as long as the fuse has been cut off, the arc will be cut. The fuse will be cut into two. So there is no how that it will be difficult for you to avoid them or cut it off. What I mean, which will be difficult to avoid and cut off. You cannot avoid it. That is just how it is. Hence, usually the electrodes of the DC fuse are placed at large distance when compared to the AC fuse. This will minimize the chance of arc and since the distance between the electrode is increased, the size of the DC fuse is comparably large. It's as simple as that. What I am trying to explain here is, in terms of the DC, the distance of DC is different from distance of AC. That is that is one thing I want you to understand. The distance between the DC fuse placed at the larger compared to AC fuse, and that is another thing. And since the DC constant value is always above 0 volts, and remember what I said here, which there is a chance of an electric arc between the met wire, which will be difficult to avoid and cut off. But what I want you to understand here is the main difference of DC and AC fuse is the size of the fuse. That is the main difference. And in the standard DC, when the current exceeds beyond the fuse rating, the fuse will cut off, so that to protect the circuit. Now, AC fuse. The AC fuse are categorized into types. They are the low voltage fuse and high voltage fuse. The frequency of the AC fuse changes its amplitude from 0 to 60 degrees Celsius in every 1 second. Remember, the difference, as in the frequency of the AC fuse changes its amplitude from 0 degree to 60 degrees Celsius in various 1 seconds. Thus, the arc extension in the AC circuit can be done easily as compared to DC. Remember, in terms of DC, it's very difficult being the arc, while in DC is easily done compared to AC. And another thing is, always know that the frequency of AC fuse changes its amplitude from 0 to 60 in very 1 seconds. Now, in that case, this is how it is: AC fuse types and so on and so forth. And this one is high voltage fuse and low voltage fuse. Remember what I said about high voltage and low voltage. High voltage uses a voltage above 1,000, 1,001 and above, while low voltage uses a voltage from 0 to 999 volts. Thank you once again for watching my video. Please, if you find my video useful, subscribe to my channel, comment, like, and share. Thank you once again. See you in the next class.